As we're going to be looking at this question on simultaneous equations, let's have a quick read. So we've been told that L is a straight line, and you've been given the equation of this line here, and then you've got C is a graph with equation given here. Now this is not a typical type of graph equation that you're used to at GCSE, and you wouldn't be expected to know what that graph looks like. I am going to do a quick sketch on the side, but you wouldn't be able to do that in an exam without plotting it accurately. Or trying some numbers, which you don't have time to do in an exam. It says using algebra, so it's specifically saying what method to use. Find the coordinates of the points of intersection for the two curves. Now, if you scroll down to where you're meant to put your answer, you can see actually it's got two pairs of coordinates. So we know it's going to intersect at two different points. And you know this is also a 5 marker, so there's going to be quite a bit of working out involved with this. So let's get started. Now, because the other way you would solve this is to plot the graph. When you're solving simultaneous equations with two straight lines, one going here, maybe one going here, well, the coordinate where they meet is your x, y value, and that's the solution to the graph. What we have here, however, is not even a quadratic. It's a different type of function, but basically it's going to look roughly like this, and you wouldn't need to know this, but it's good to be able to visualize. So you've got y equals 2x minus 5 would kind of look like that, and then you've got 6x squared, y squared equals 6x squared minus 25x minus 8. So it might look something like, if I do this in orange, something like this, and it's got 2 points of intersection. The fact that it's this shape that I've just drawn doesn't really make a difference. You just need to know that it crosses over at 2 different points. So we're going to use algebra to solve this. Let's have a go. Okay, first thing is we are going to you always label the equations. This is going to be 1, this is going to be 2. And you always put the linear equation into the other one because it's much easier to do it that way. So if this is what y is equal to, here, let's just circle that in a different color. So this is what y is equal to. You're going to now replace this y here with what that is over there. So let's just rewrite this. We're going to write 2x minus 5 all squared equals 6x squared minus 25x minus 8. Now, when you're squaring a bracket, it's basically writing the same bracket twice like this. This is going to be a bit clearer. We're squaring it. We're now going to expand this all out. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x, another negative 10x. Negative 5 times negative 5 is plus 25 equals 6x squared minus 25x minus 8. Now I want to do move everything over to the right hand side. So I'm now going to take away 4x squared, take away 4x squared. I'm going to add 10x, add 20x in one go to get rid of that. So add 20x here. And then I'm going to take away 25, take away 25. So I'm going to do all of that in one step. So 6x squared minus the 4x squared here will give you 2x squared. Adding 20x to both sides will give you negative 5x, and then we are taking away 25 from both sides, which is, so negative 8 minus 25 is negative 33. That's now equal to 0. This is now a standard quadratic, ax squared plus bx plus c. We can do a bunch of different options here. We could use a quadratic formula. We can factorize if possible. We can complete the square. Let's see if we can factorize first. So in order to factorize it, something has to multiply to AC and add to B. So, well, A is that, B is negative 5, C is negative 33. So A times C, 2 times negative 33 is negative 66. And B is just negative 5. So what adds to negative 5 multiplies to negative 66. Let's just have a quick check. What can it be? So 1 times 66 doesn't work. 2 times 33. 3 times 22. 6 times 11. So I think we can make negative 5 from that if the 11 is negative. So we're now going to split the middle term and factorize. You may have decided to use a quadratic formula as well. That would be just as valid. So this becomes 0 equals 2x squared. And then this splits up into two values. Those are meant to be arrows, not very neat. So this becomes minus, so plus 6x minus 11x minus 33. I'm going to draw a line down the middle. I'm going to factorize the first bit. We're going to factorize the second bit to work out what our brackets are. So this is going to be 2x times x plus 6. Sorry, x plus 3. And then this will be minus 11 times x plus 3. The fact that these two brackets are matching is good. If they didn't, then we've gone wrong somewhere. That's our first bracket. And then our second bracket is these two terms here. So we're going to write 2x minus 11 brackets x plus 3. We have now factorized our quadratic. We are now going to solve it. So we can say 2x minus 11 equals 0, or x plus 3 equals 0. So that means that if I add 11 and take away 2, I end up with x equals 11 over 2. Or if I take away 3 from both sides here, x equals negative 3. So we now have our two x values. On the coordinates on this graph here, we've basically got the two x values, and to work out the corresponding y values, we are going to need to substitute these x values back into the original equation. Now we could also substitute it into the second equation. They will both give us the same answer. However, you can see quite clearly that substituting into here is just going to make another messy quadratic, another thing to solve. So it's just much easier to just substitute it into equation 1. And you can actually just say that to the examiner by saying x equals 11 over 2 into, and then 1, and x equals negative 3 into 1. Okay, so I'm just going to tidy this up slightly. Okay, I'm just going to move this to the top a little bit, or to the middle, and then we're going to do our substitutions. Now we know that equation 1 is 2x minus 5, y equals 2x minus 5. So y equals 2 times x, which is 11 over 2, minus 5. So that's 11 minus 5, which is 6. And here for this one, y equals 2x minus 5, x is negative 3, so 2 times negative 3 minus 5, which is negative 11. So our solutions here are x equals 11 over 2 and y equals 6, and x equals negative 3 and y equals negative 3. So we need to write these as answers at the bottom of the answer space, but I'm just going to write them in this box here. The solutions are 11 over 2, 6, and negative 3, negative 11. You can write this as a fraction if you want to, as a decimal if you want to, but either way, those are your answers. And like I said, if you decided to use a quadratic formula here, you would end up with the same answers. I hope that's useful. Let me know.